Hello, in today's video we will discuss the types of t-tests and when they are used. So first let us understand that what are we trying to find. If we are trying to find, if we are comparing some groups, if our objective is to compare some groups and see whether they are different or whether they are the same, we use t-tests. If we want to find out the relationship between groups, we do an exercise called as correlation. And if we want to predict the outcome of one variable by another, where we have an independent variable and dependent variable, or multiple independent variables and a dependent variable, we use an exercise, or we use a test called as regression, or we do an analysis which we call as a regression analysis. Regression analysis is also called as predictive analysis by some, but today's topic of discussion is t-tests. So let's have a look at the type of t-tests that are available to us. If we want to compare the differences between two groups, we actually look at independent sample t-test. Why do we call it independent sample t-test? Because the samples are coming from two different groups. So it could be male, female, it could be company A, company B, it could be different countries, it could be different states, it could be different cities, it could be different individuals. So such an exercise is called as a independent sample t-test. Paired sample or dependent sample t-test, when the sample is coming from the same set of respondents, and it is usually done in the case where we have a pre and post scenario. What do we mean by pre and post scenario? For example, we want to see what is the impact of gymming on people. So what will we do? We'll collect a sample of all those who have just joined the gym, that is pre-gym, and after a period of time we take their weights again and we make a comparison to see if there is any significant difference between gymming, pre-gymming and post-gymming. This scenario, this pre and post could be applied anywhere. Let's say for the case of vaccination, COVID vaccination. So we can look at the antibodies of a group of people who did not have or did not have COVID or did not take COVID antibodies. We measure their antibodies level, that is pre-level, and then we administer them COVID vaccine, and after a period of time we see whether the level of antibodies have increased or not. So we are basically trying to see whether there is a difference between pre and post treatment. Same is the case in independent, but in independent the samples are different, but we are not looking at pre and post. One sample t-test is different from the other two for the simple reason that in one sample t-test we have a scenario where we don't have another group, we only have a sample from one group. But what we are trying to do is we are trying to assess whether this sample mean, the sample mean is equal to, as our null hypothesis says, is equal to the mean which we are trying to compare ourselves with again with. So what happens in one sample t-test? We have a benchmark against which we compare our sample mean and statistically see if it is different or not. So such a test is called as a one sample t-test. One classic example could be the stress level of employees, or you can take an example of the salaries of employees. So let's say in a company there are thousands of employees and there is a claim. Somebody says that the average salary in that particular company is 50,000 rupees a month. So that's the test value. So what do we do? There are more than 1,000 employees. We collect a sample which is random, probably 50, 60, and we calculate the sample mean and statistically compare this calculated statistical mean with the hypothesized value of 50,000 rupees. So this is what we do. So let us go and have a look at which test to use. Now, before we start that, I would just like to point out, in the case of independent sample t-test, there are two possible scenarios where you have equal variances and where you have unequal variances. So when the sample sizes are different, In independent sample t-test, because the data is coming from two different groups, the sample size could be different. So generally speaking, when the sample sizes are different, we can go in for assuming unequal variances. In paired sample t-test, always remember, because the data is coming from the same set of respondents, so we have to have equal matched pairs. So sample sizes cannot be different, they have to be matched pairs. One sample t-test, the data is only coming from one sample. Now all these three tests can be performed on Excel, but today we will be performing these tests on Excel template. So let's move on, let's see how these things are done. So let's go ahead and let's see how this can be done. So we have a one sample t-test example. In this case, as we can see, I'll just highlight this, and you can see we have some employees from whom the data has been drawn. So this sample, so we have approximately 21 employees, and the data comes from 21 employees. That is, this data has been obtained randomly, and these are the salaries, different salaries of different employees. So employee number one, so this is basically the employee number one. Although we have a number, it's just a label. So we could have had a name. So it could have been Atul, and this could have been Vipul, and this could have been Raj, and this could have been any name. So instead of names, we have just chosen to write the numbers 1, 2, 3. So this is basically a sort of coding. Their salaries are mentioned here in 1000. Okay, so 21 employees, random employees, and their salaries have been. Now what is the hypothesized value? What does this mean? It means that the our hypothesis is that this is our alternate hypothesis. Our alternate hypothesis is that the mean salary in this particular company from which the data is coming from, the mean salary of the individuals is 30,000 per month. So we have taken the data and we'll run a t-test and we'll see whether our salary, the mean which we calculate along with the confidence interval, does this fall in this, and I mean whether this is the mean that is predicted, which is this, and this is similar or not. So that is what we are trying to do. So in Excel, you don't have an option of doing a one sample t-test. I did explain it to you how this can be done, but what we'll do now today is that we'll do it with the help of an Excel template. So in the templates, you can quickly go to one sample t-test. I have named the template as one sample t-test, and as soon as you open this, you have to go to the worksheet which is labeled as sample data, because we have the data here, we have the raw data. So your sample data would look something like this. So the first thing that you need to do is you need to copy all the data and delete this data. And once you have deleted the data, you go back to your one sample t-test and just copy all the values in the column, and you just copy this. You come back again to your one sample t-test and just paste the data here. So I'm just pasting the data, and as soon as I paste the data, the analysis has been done for me. If the first thing that I have here is the sample size and the sample mean. Okay, so the sample mean for my sample has been calculated, which is 33.4318, and I have a sample size of approximately 22 individuals. Okay, so it must have been 22. I was wrong when I was saying 21. So it must be 22 individuals. Now I have to go to the bottom part. Okay, I don't have to visualize this because it says sigma known, normal population or sample size is greater than 30. In my case, the sample size is less than 20. So it's less than 30. So I need to go down. I need to look at this particular table. Okay, and when I look at this particular table, I have to change this mu, because our mu is, what is our mu? The test value is 30. So for this 30, I need to change this. Okay, so what happens? I need to look at the evidence is basically your summary statistics. 22, 33.4318, which is the sample mean of the mean that we have, sample mean. The sample standard deviation is given. These are summary statistics. These are inferential statistics. So we need to look at the t statistics. T statistics is telling us that it is 4.5391. Now what does this t statistics mean? You don't have to evaluate this, but what does it mean? It means that the difference between the hypothesized mean, okay, that is your hypothesized mean is 30 and your sample mean, the difference is, the t difference is basically 4.5. Bigger the difference, more is the difference between the two values. So okay, so this phenomena is universal to independent sample or paired sample or one sample t-test. If t value is big, that means there are differences between the groups. So t value is an indicator whether your whether the findings are significant or not. So when do we say significant? When there are difference between the groups. So let us look at the significance level of 5%, because that is the chosen significance level. We can change this. So let's assume that you have 99% confidence level, so you can just change this to 1%. So in our case, generally the trend is, and in our case also it is 95%. So significance level is derived from the confidence level. So confidence level, if it is 95, significance level will become 5%, and in decimals it becomes 0.05. So we write 5% here, and the best part about this Excel template is that it tells us that the null hypothesis is rejected. That means there are significant differences between the group. That is, the salary of this particular the salary of this organization, the average salary is not equal to what our hypothesized value of 30,000 per month. That means the salary is different. It is not 30 from this sample, the conclusion that we are drawing. So it is not 30,000 per month. So now when the findings are significant, we know that this is not 30. Then what is it? We go back and look at our sample mean, which is 33.43. So we say that the salary is more than 30,000 because our sample mean is more than the hypothesized value. So we'll say in this case, it could have been less also. Then we would have said the salary is less. So difference could be either ways. It could be either ways. It could be less or it could be more, but it is not the same. That means statistically the salary is not the same as our hypothesized salary of 30,000 per month. So this is how we do the test. This is basically the first test that you see is a two-tailed test, okay, where it is equal to sign, and this is your one-tailed test, and this is again your one-tailed test, but this is more than and this is less than. So if we would have had a less than hypothesis saying that the sample mean is less than 30,000, so we would have also rejected that. Okay, so that's how it is. This is how your one sample t-test is interpreted. So we'll now move on to so this is an example of one sample t-test. What do we have here? We have two groups. One is KFC, the data is coming from KFC Connaught Place, the other is coming from KFC Lajpat Nagar. We want to see, and these are the sales figure, daily sales figure. That is how much sales in thousands of rupees have they generated every day. So KFC Connaught Place has a sale of 88.24 the first day, and the same day KFC Lajpat Nagar has a sale of 60.02. So this data is coming from, there are two columns. One is KFC Connaught Place data and the other is KFC Lajpat Nagar. Now we have data like this, and as you can see there are some gaps here, but these gaps are alright as far as it is an independent sample t-test. I have already told you the data does not have to be matched when it is independent sample because the samples are independent. Okay, so you could have some missing data, or even the sample size could be slightly different. So one could have a sample size of 200, the other could be 205. But when it comes to paired sample, the sample size have to be matched and the data has to be there for the pair. Okay, so this is the difference between one sample. So what do we do? The same thing. We'll go back to, we'll open up our template. So we'll open up our independent sample t-test template, and again we'll go to the worksheet called as t-test from data. So we already have some data here. So what we'll do is we'll just simply delete this data. Okay, and we can put our names here if we want to. So we can write uh, this is your CP, KFC CP, and we can, if you want to make it simple for us, otherwise there's no need to write if you can associate. And this data is coming from Lajpat Nagar. So what we'll do is we'll simply go and we'll copy our data. So we'll just copy the data. So we'll just copy the data, and let's say this is the data that we have, and we'll come back to our independent sample t-test, and we'll just paste the data here. As soon as we paste the data, we get some analysis here. Now the first thing that we need to look at in this is basically the assumption, the first assumption. Has it been met? Only then we can go and assess if the t-test is, whether we should analyze the t-test or not. So first we need to look at this particular assumption, and if this p-value is less than 0.05, we have to look at the first table, because there are two tables which we need to analyze. So we can, if this is less than 0.05, we need to analyze this particular table. Okay, and if it is more than 0.05, that means that there is no significant differences in terms of population variances, and we can assume population variances are equal, and we can analyze the first table. So if this would have been significant, we would have had a warning here. We would have had a warning here, and we would have to go down and interpret this. So in our case, the population variances are equal, so we'll have, and the null hypothesis is not rejected, and we will analyze the first one. So always remember, if this value is less than 0.05, you will get a warning here, and that means you have to analyze this table. Otherwise, if there's no warning here, and if this is greater than 0.05, which will always be, if a warning is here, it will always be greater than 0.05. Sorry, less than 0.05. And if it is greater than 0.05, there will be no warning here. Always remember that. So in this case, there is no warning here. That means population variances are equal. So we can go ahead and analyze this table. Okay. So we can see the sample size is 39 for the first sample, and for the cannot place data, we have 39 data for 39 days, and for Lajpat Nagar KFC, we have for 41. And if we look at their mean sales, so we can see from here itself that the mean sales are different, but are they statistically different? That is what we have to look at. So we just go down and we look at the t statistics. T statistics, like I said, tells us whether the differences between the group is small or large. If you look at this t value is pretty large. It is 11.71. That means the difference between the group, statistical difference between the group, is pretty large. So this tells us, this is an indicator that there are differences between the two samples. That is, the mean of the sample of Connaught Place and the mean of the sample of Lajpat Nagar are different, and that is reinforced, and that is vindicated with the help of this, the p value. And the p value, as you can see, is highly significant. It is 0.000, which is less than 0.05, which is our significance level. Chosen significance level is 5%. So we reject the null hypothesis. And the best part about this software is it tells you that you need to reject the software. And what is the null hypothesis? That there was no difference between the sales, average daily sales of Connaught Place and average daily sales of Lajpat Nagar outputs. Sorry, your two different outlets. So we reject the null hypothesis. So we need to examine this, and this tells us we need to reject the null hypothesis. That means there are differences between the sales, daily average sales of Connaught Place and Lajpat Nagar. And if you want to say who's selling more, you can just look at their mean. So you can say that simply. You can say that since the mean of sample 1 is more, which is Connaught Place outlet sells more than the Lajpat Nagar outlet, and that is statistically different. Here only the means are different, which you can see, but here you are saying that they are statistically different. Not only do they look different, they are statistically different. That means, to be honest, their confidence intervals do not interlap, and that is why they are statistically different. So from here we move on to paired sample t-test. In a paired sample t-test, what do we have? We generally have a pre and post setting. And so we call this as pre-treatment, post-treatment, whatever way you would want to call it, control and treatment groups. It could be anything. So in medical sciences, we call them as control and treatment group. Control could be the one which is not administered any drug. Treatment is the one which is administered any drug. And then you see if there are any differences which have come up. So I have some data here, and this data is pretty interesting data. Okay, and it comes from some Latin American country, which is kept anonymous. The only thing is the data says that in that particular country, there were economic reforms which were initiated in 2010. Prior to that, there were no economic reforms. So this was their GDP. Okay, it could be in billions or it could be in millions or whatever. These are the some numbers of GDP. And post economic reforms, once the reforms were initiated, again the GDP was measured in 2020. So some 10 years were given, because the reforms take some time, lagged effect, like vaccines. So you get the vaccine, you don't see the, you take the, you take a sample only after a month or 1.5 months to see that you have achieved the desired level of antibodies. Same is the case with uh, same is the case with uh, our economic reforms. Economic reforms take a lot of time. So uh, we have data from a pair, that is the data is coming from the same country whose sample remains the same, but this is at point 2010, that is it was taken at a time 2010 and this was taken in 2020. So this is again a pre and post setting, pre economic reforms and post economic reforms. So we can do the same exercise in Excel and we can do it in uh, Excel template. So what we'll do is we'll go to our Excel templates and you search for paired sample. So you search for paired sample t-test Excel template. Okay, it is there in your template folders on the Google Drive. So what do we do? The first thing, we need to look at the sample data. We need to find the worksheet sample data, because we have sample data, raw data. We don't have the statistics from the data. So what we'll do is we'll simply delete this. We'll come back here and we will just copy the, so this is the pre and this is the post. So you need to know that this is pre and this is post. So your first column is pre and the second column is post. So you can just simply copy them. So I'm just going to copy this and I'm going to come back here and paired sample. I'll just write this. So it says current and previous. Okay. So, but since we are only testing the differences, we are not testing which is which or more or less. So we need not be very, we can just put in, it doesn't make any difference. We can just put, copy and paste the values. But otherwise, if we would have wanted to find the direction and if this would have been a one-tailed, test, then we would have had to put it in the right order. But here we are only interested in finding whether there is any difference between the groups or not. So even if we don't change these, this comes here and this goes here, it doesn't make any difference. Okay. So let's look at the t statistic. The t statistic says there is a difference. Okay, and this difference is -233. Now, since there's a difference, but the problem is that since the data has been taken and the data has been input in reverse order, so we need to analyze this t statistics. It is coming out negative, saying that pre-test it was more and post-test it is less, the growth. But actually, since we have put in the data in the reverse order, so we need to interpret it accordingly. So what we could have done was, we could have simply gone back and we can just simply undo the data and we just paste it in the right place. So we need to copy this, which is the post data. Okay, post economic reform. So we'll copy this and we'll come back to our paired sample and we'll write it here rather than the second. So this is post, which says current. So we can write 2020. So we can, just to make it clear, we can 2020, and this is going to be 20 data from 2010. And we go back again, we copy paste the data from this The t statistics is going to remain the same, only the sign is going to change. Now you can see for yourself. So we come back and we just paste it here, and we can see the t statistics is the same, but the only thing is it has become positive now because the direction has been changed. So sample size is 51, and the standard deviation is given, and the average difference is also given between the two groups. Okay, so the average difference is 0.880. So difference between mu1 and mu2. So we were saying mu1 minus mu2 should be 0, but it is not 0. And our t-test t-value is saying that yes, there is a difference. So bigger the t-value, more is the difference. So the difference is not very big. So that is why the t-value is not very small. But statistically, there is a difference. It says we should reject our null hypothesis. And why? What does it mean? It means that post-economic reforms, there have been, the GDP has gone up. So that means we can say that with conviction that the GDP, the economic reforms were good. How good? You will have to evaluate using the means. But by simply the t-test, you can simply paired sample t-test, you can say that the pre-economic reforms and the post-economic reform situation is different, and post-economic reforms, the country's GDP has gone up because your t statistics is positive, and we know the average difference is also coming out to be positive. So this p-value, you can see it is less than 0.05, and that is why we reject it at a 5% significance level. So this is how a paired sample t-test is done. So t-tests, all the t-tests, one sample, paired, independent, they work on t-test, the t-distribution. So they make use of the t-distribution. They don't use any distribution. Whereas in independent sample t-test, the only place where you use an F distribution is to just test the assumption. And once you test the assumption, then you look at the t-distribution and the t-values, and based on that your p-value is computed. So always remember this. There shouldn't be any mistakes. Now we move on to more than two groups. Let's assume I have three groups, and this is party A, party B, party C. This could be visualized in different ways. It could be factory A, factory B, factory C. It could be unit A, unit B, unit C. It could be KFC, Cannot Place, KFC, Lajpat Nagar, KFC, some other place, South X. So these groups could be more than two, and when they are more than two, we use a technique called as analysis of variance, ANOVA, analysis of variance. Always you need to remember this analysis of variance. ANOVA is a short form for analysis of variance, and it is used for more than two groups. So when we have more than two groups, we'll use analysis of variance. Now this exercise can be done in Excel, and it can be done in your templates. So we'll go to, first we'll do it with the help of template, and then we'll do it with the help of Excel. So simply we will go to our ANOVA template. So how do we go to the ANOVA template? We have to go to our templates folder, and I'll just select ANOVA. And as soon as this ANOVA comes up, I have to go to this worksheet, which is called as one-way ANOVA. I need to delete this data. Okay, so the data which is there, I need to delete this. What do I need to do? I need to come back and copy my one-way ANOVA data. So this is my data, party A, party B, party C. I can just simply copy this data, and my data is, I think, 99 or 100 exactly. So I just come back here, and I'll go to my ANOVA table, and I'll copy this data here. I just paste the data, and as soon as I paste the data, it tells me the sample size is 100 for all the three, and it gives me the table which I need to refer to. So this is my ANOVA table, and let me just explain this to you. So in my ANOVA table, what do I have? I have the sum of squares. This first is the sum of squares, and this is the sum of a square between the groups. So I have three groups, and I have individual groups A, B, and C. So 1, 2, 3, these are three groups. So when this sum of square is calculated, you must remember that we did that in standard deviation. You are not required to calculate the sum of squares. Nobody is going to ask you to calculate the sum of squares. The sum of squares is basically calculated between the groups and within the group. So this is 14196, and this is within, that means individual groups. What is this degree of freedom between? So we have three groups, 1, 2, 3. That means 3. What is our formula? Degree of freedoms when we are talking of between the groups. So there are three groups, n minus 1. So how many groups? 3. 3 minus 1 is 2. If we would have had 4 groups, this would have become 3. If we would have had 5 groups, this would have become 4. Now it is also talking of degrees of freedom within the groups. So now each group has 100 sample size. So the degree of freedom within the group is n minus 1, 100 minus 1 is 99. This also 100 minus 1, 99 for group B, political party B, and for political party C, it is also going to be 99. So there are two ways to do it. Add all these up, 300 minus 3, because there are three groups, or 99 plus 99 plus 99, it comes out to 297. So you may be in an exam, you may be asked to calculate the degrees of freedom. The data may be given to you, you may be asked to simply calculate the degrees of freedom just by giving you the sample size and the groups. So you can calculate these two in that fashion. What is this MS? That is the mean sum of squares. So this sum of squares divided by this degree of freedom gives you MS. So 14196 divided by 2, 7098. What about this one? So this within group sum of squares divided by degree of freedom of 297, it gives you 59.577. And what about this F value? This F value is MS divided by MS between the groups divided by MS within the groups, gives you this F value of 119.10, and you have this F critical at 5%. So again, the significance level. The significance level is for all the tests, whether it is t-test, ANOVA, regression, correlation. It will be a universal significance level, and generally people tend to choose 5%. Now always remember, there is something which is very important. This F value that we are talking of, okay, so you need to note this. This F value that we are talking of, this F value, if it is greater than your F critical, the results would always be significant. So in this case, 119 is way more than 3.0262. So this value will come out to be significant, and it is significant. So what is this ANOVA telling us? This ANOVA is telling us that there are differences between the groups. So the null hypothesis here is that there are no differences between the groups. That's how we start saying that there are no differences between the group. And what is our alternate hypothesis? That at least there is one difference between the pairs that we can have, A or B, A and C, B and C. So there are three groups. So there could be differences between any one of them. So as long as the differences are there, even if there is a difference between one group, one pair of group, your null hypothesis gets rejected. So it is saying reject the null hypothesis. So what does our result say? Result is significant. From here also we could have found out that it is significant. This is also telling us. So how do we compute this p-value? This p-value I have already explained to you in the video. I'll explain it again. We use the function F inverse, and F inverse we will choose our hypothesized probability, which is 0.05. When we write equal to, in your exam you may be asked to compute the p-value. So how do you compute the p-value if everything else is known? You will write in a cell, you will write equal to, and you will use the function F inverse, okay, and in bracket you will write this p-value, which is 0.05, comma, your degrees of freedom 2, and which is your next degree of freedom, which is 297. Okay, so you can simply compute. So this is what the software is going to ask you. These three values are very important. Okay, so I'll explain this in a few minutes from now on, how to compute the p-value. So in an exam you may be asked to compute this, 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 you may be asked to compute the F value, and from here you may be asked to compute the p-value. So many times what happens, they just give you a simple table and just hide some of the values, and they ask you to check your level of understanding. Okay, so what has happened? Let's just go back. I'm going to erase everything. I'm going to erase everything now and we'll just go back and see. So what were we discussing? That if there is any group difference between the groups, our null hypothesis gets rejected. That means there is some difference between the group. Okay, so we'll come down and we can see for ourselves that Excel, by the way, Excel, standalone Excel will never tell you what, it will only tell you there is a difference, but it will not tell you the differences, which groups are different. So for that you will have to do some additional test, and that is very, very complicated. The best part about Excel is it tells you whether there are differences between the groups or not, and it tells you which groups are different from each other. So A and B group are different. So A political party and B political party are different. Their means are different. Similarly, political party A and political party C are different. Their means are different. So these two groups are different, but C and B are not different. C and B, the means are nearly the same. Now, it also gives you a visual, analysis to show you that how groups are from the mean, how spread out, and you can look at the means also. So you can see political party A has 64, political party B has 78, and political party C, the mean is 81. So if somebody were to ask you which party is likely to win, so you'll simply say that party C is likely to win because it is going to get most of the votes. It says 80% or more than the rest, 65, 78 and 81. So a question could be asked to you like this. So there are three ways where you could have to do an ANOVA analysis. One, you could simply do an ANOVA analysis like this and report the results, whether the findings are significant or not. The other thing could be you may not be given the raw data, you may just given be the you might be given the sample statistics, and from there you may have to, you might be given an ANOVA table like this, and once you are given an ANOVA table like this, you may be simply asked to compute some of the things. Okay, so you may be asked to compute, for example, you may be asked to compute this, you may be asked to compute this, you may be asked to compute this, you may be asked for this, you may be asked for this, you may be asked for this, and they are all very simple. Degrees of freedom between the groups, 3 groups. If there are 3 groups, degree of freedom becomes 2. And within the groups, you look at the sample size, n minus 1, n minus 1, n minus 1. So if there are 3 groups, add all of them, all total sample size divided minus 3, or you can simply do it the other way around. 100 minus 1, 99, 100 minus 1, 99, 100 minus 1, 99, 297. So if the sample size is different, let's say 37. So this will be 29, this will be 29, and this will be 29. Add 3 of them, that will give you your degree of freedoms within the group. So your MS is SS divided by degrees of freedom. Okay, so these are the things that you need to know as far as the ANOVA is concerned. So I think that is it for today, and just to show you how the F value is computed, the P value is computed. P value is already given to you. You may have to compute the F critical. Okay, so this F critical at 5%, how it is computed, this could be a question in your it could be, I'm not saying it is going to be, but it could be a question where you may have to compute this F critical apart from all these. The P value, you may not be asked to compute the P value, you may be asked to compute the F critical. So let us see how this F critical is calculated. So we'll go back to our one-way ANOVA example, and we can simply go to data. I'm just using Excel to demonstrate this, so you can just see. So I'm going to go to one-way ANOVA, the first single factor, okay, and I need to input the data, so I'll just go here and I'll control shift and I'll down and I get the entire data set. Labels in the first row, output is pretty simple, so I'll need the output somewhere else, so I'll just select the place where I want the output to be and I'll hit the button here and I'll get the output. Okay, so I get the ANOVA table and I get the final things. Okay, now sometimes you may be just given this data, the data that has been highlighted, which you can see. So you may be just given this particular data and you may be asked, you might just be given this only this, you may not be given this. So that summary tables may be given to you and you may be asked to compute, let's say, this degree of freedom. So what you will do is, there are three parties A, B and C without having a look at this. So there are three groups. So three groups means n minus 1. So this is your degree of freedom. So this is your first degree of freedom. Okay, for between groups. Then sample size is 100, 100, 100. So you add all these up, this becomes 300 minus 3. This is your within groups degree of freedom. So this divided by this will give you this. So this is actually 2, and this is 17694 divided by 297 gives you this. This f value, the f value that you see, this f value that you see is nothing but this divided by this. You get the f value. Now the question is how to get this this f critical. So the way to get f critical is you just write equal to f inverse. So you will use the f inverse function, and f inverse the probability. So what is the probability that we are talking of? It is 0.05, and the degree of freedom is 2. Sorry. So degree of freedom, comma, I need to put a comma. Degree of freedom is 2, and which I've just selected the cell, and the other degree of freedom is 297. So I'll just hit the button enter and I get the F critical. So this is how the F critical is computed. So if you are asked to compute the F critical, you can do it here. So if you get a table like this, and you are asked to compute these values, so you don't use the Excel template, you just do it here. So the data would be given to you. So for example, in your exam, you are not given any of these data. You are only given this summary statistics. So let me just copy it here, and the data is given to you in this form. So the question may be given to you in this form, and you may be asked to compute some of those values. Okay, so I'll just beautify them a little bit, and some of the values may be hidden, and you may be asked to compute, let's say, these two values. So I'll just hide them, or you may be asked to compute one of these. You may be asked to compute this, and you may be asked to compute this. So you need to know how these are computed. So it could be hidden. These values could be hidden, and you may be asked to compute them. So you know how to compute the F critical. I've told you, you have to use the F inverse command. For degrees of freedom, you already know there are three parties. So n minus 1, 3 minus 1 is 2. This becomes a 2. Okay, so this becomes a 2. Similarly, for this one, what is the degree of freedoms? 100 plus 100 plus 100, 300 minus 3. So this becomes your 297. MS is nothing but this sum of squares divided by degree of freedoms. You get the MS, which you can see 14 divided by 2 will approximately be 7. And this is equal to this divided by this. And your F value is very simply MS between groups divided by MS within groups. So this value divided by this, you will get the F value. And for F critical, you use the F inverse function, which is your chosen probability, your chosen or your significance level is 0.05. You put the significance level as 0.05, and C10 is basically this 2 first degree of freedom and the second degree of freedom. You just enter these. So that's what your software. The software also asks you probability, degrees of freedom 2. Okay, and you compute the. And why do we use F inverse? Why do we have an inverse function here? Because probability is actually not, probability is 95, but significance level is 0.05. So what is the inverse? 1 minus. So we are using an inverse function. So we don't have a function to calculate it directly. So we'll use the inverse function. So we call the inverse function. So we put it as 0.05. And once we do that, we'll hit the button enter and we get the result, which is the same. So you may be asked to do this. So you could get the question in either form. Either you get this table and don't get the data and you analyze this, or you get the data and then some questions may be asked to you from the data. Then you may not have to do this exercise. So that's it.